So we're going to start our last session of the afternoon before the technology showcase and the refreshments. I'd like to introduce and bring up to stage Stefan, who is the CEO and co-founder of NAUTO. And Stefan is going to be sharing with us his experience and his perspective on making existing cars smart via the integration of embedded vision plus deep learning. And Stefan is a recognized expert in a number of markets with regards to clean tech, energy, and automotive. And prior to that, ran a global practice at McKinsey. And in addition to that, he brings deep knowledge in artificial intelligence as a PhD in deep learning and neural networks. So it's double deep with Stefan here. And,
Thanks
and
very
so
much.
I want to welcome Stefan to the session today.
Thank you. Good afternoon. So at NAUTO, we're retrofitting AI and computer vision to vehicles. And I want to tell you a little bit about how big a difference that can make and why some of what the last speaker, if you were here for that session, talked about is in fact the case. You can make incredibly challenging algorithms actually lightweight enough to run in a retrofit mobile phone type environment. But first, how many of you own a car? Yeah, funny question here in Santa Clara where you have to drive to get to this place, right? So pretty much all of you. And most of you probably bought your car to drive it. Is that right? Safe assumption? I have news for you. You actually bought your car to park it, because that is what you do 96% of the time. Of the 4% of the time that you're in your car, half of it is looking for parking or stuck in traffic. So you get about 2.3%, 2.5% use out of your car. Not very fabulous for a $20 trillion investment globally that we make in vehicles. We also burn a lot of fuel. Unless you're driving electric, then you're good. But if you're driving anything internal combustion, only 1% of the energy or 1% of the oil you put in your car actually moves you forward from A to B. The rest is all waste. We also use our infrastructure very sparsely. At peak loading, which is about 2,000 cars per lane per hour, you get 10% coverage of the road. Here in Silicon Valley, that happens a bit more often, but nationwide, that only happens about 5% of the time. We get it about 10% of the time, but we get a lot of time where throughput breaks down because it's traffic jam. So that's a 0.5% utilization. And then we kill 33,000 people every year. If this were a disease, it'd be all over the news as an epidemic. It's much more serious than terrorism, much more serious than Zika or any of the other things that people are currently worrying about. So transportation today, in a word, it sucks. We have 99% waste in the entire system, and it really costs us $3 per mile. The reason you don't know that number is you only pay about $1 per mile. The other dollar you pay indirectly through your taxes in terms of infrastructure that we build for cars. And the third dollar is unpriced externalities, like the days that you're off work after you got into an accident, the time that you waste while you're in congestion, all of those losses. So really, it's about $3 per mile all in. And I want to show you what difference deep learning and embedded vision can make to actually begin to tackle all of these issues, at least in part, and to do so relatively quickly. Because those are the goals that we really want to achieve. You've heard Google talk about autonomy, trying to save lives, but it's the full set. There's already a lot of giants in this space, right? So we have Google building autonomous cars, trying to go after the 90% of accidents that are caused by human inattention and human mistakes. So that's great. We also have many companies, not just Apple, going after connecting the car and making them smarter, giving us real-time traffic information. Waze would be in this category. Many other companies that are trying to make modal connections easier and optimize where we drive and when we drive. We have Tesla, who's shown us that electric cars can be not just efficient and better for the environment, but actually sexy and wicked fast and safer. So that's a good step. And we have Uber, who's taught us how to share. At least share vehicles. We can share a lot more, obviously. And the interesting thing about sharing is that 2.5% utilization goes to 50 if it's a well-managed passenger fleet, and can go to 70, maybe even a little bit higher if you start doing deliveries in the off hours. 70% utilization from 2% utilization is a 35x increase. You guys can all do the math. That is like the advent of the railroad or the steam engine, order of magnitude and more change in productivity of a fundamental base technology that drives a lot of what we do in the economy. So these changes are giant, but I'm here to show you that this is only part one of the fix. Why do I say that? Well, part two is these technologies actually interact. If I have autonomy and I'm connected, I can now actually coordinate my flow on the freeway. So one of those lanes that's a carpool lane right now on Highway 101 could turn into an autonomous-only lane. We could change the spacing from 8 car lengths or 9 car lengths to about a meter, meter and a half, which I know sounds scary, but I've seen it done in a Mitsubishi and Volvo truck, which, trust me, is a lot scarier. There's Peloton up in San Mateo, I think, doing it for trucks here right in the state. That basically means 101 turns into a 32-lane superhighway equivalent if we did that to all the lanes. Now, that's fully autonomous, so we won't get there overnight, obviously. But that's a gigantic change. We'd never build another road. We just get increases in productivity from the roads we have. Think about the electric side. If I'm electric and I'm shared, I don't need this big 200-mile battery the whole time, right? The average trip length is between 8 and 12 miles, depending on what city you look at. For 12 miles, I can buy a really cheap battery. Even if I doubled it and said I need 25, 40 miles, that'd be very cheap to be in the money today for the upfront cost. It's already cheaper to drive electric per mile that you actually drive it, so it's really just an upfront battery cost problem. Now, if I share, I can swap in and out of different vehicle types and batteries as I need to. I call this idea autonomous, connected, electrified, shared ACES, with the obvious connotation of this is the ace that will win. There's no company actually doing all 4 of those right now, but that's what's coming. So that's where we're headed. Big picture, 15 years out. You know, it's going to take some time to get there. What can we do near term? By the way, that model, if you run the pencil back of the envelope numbers, it's about 8 cents a mile down from 3 cents a mile. So it's a pretty amazing benefit. Well, we've got 2 sets. The autonomy is the hardest part of this so far. We've got 2 approaches here, and there's a real fork in the road coming. One camp is doing the incremental approach. Let's automate your parking. Let's automate your cruise control. Let's automate your lane following. But when shit happens, we turn control back to you, the driver. And I've done this in my Tesla. You have about 300 to 500 milliseconds to take control back. And usually when shit happens, that's not a good time to take control back, right? So there's a reasonable chance, in my view, that this roadmap ends in some pretty nasty accidents, and we'll see if these companies have the guts to stick through that period. Tesla certainly will, but I'm not sure about all the other car companies when people start suing them. On the right-hand side, you have some great companies jumping immediately to what's called level 4, right? Full autonomy without any human fallback. I think it's a very promising approach. It's clearly working in highly mapped, well-known environments like Mountain View in Austin and Slack, many other places, Singapore, that these cars are running. The question is, we're making a bet on how scalable that is. And I've talked to a number of these companies, and they're really scared to death of Bangalore, India, Manhattan. Those are really hard places to do the same approach in. So it will come, but it might take some time. The problem is we're killing 33,000 people in the US, 1.6 million globally, with every year that we wait. So is there a third way? Is there a way to get some of these benefits much faster? Instead of full autonomous, what if we just augmented human perception? Instead of fully connecting everything, talking to each other, what if we just ensure that cars learn from what the car a mile ahead or a couple cars ahead knows, or the car around the corner knows, so we have some level of connectivity? What if instead of fully electric, which obviously takes a new car, you can't rip out your engine as a do-it-yourself kit typically, what if we did efficiency by solving some of the big drivers of inefficiency? We solve parking, because a third of all time in cities is people looking for parking, even though we have 4 parking spaces for every single car in the United States. So there should be enough parking spaces, you just can never find the damn things. And then lastly, would you share your car if you knew everybody that got into it, how they drove, how clean the car was before and after, and whether they took any joyrides in it and did anything nasty to your car? It might make you a lot more likely to share, particularly if I told you you have 96% of the time that the car's wasting away, depreciating, when you really could be making some money on that car. So let's try to get part of the way. I sort of call this 2/3 of the benefit in a couple of years. Not exactly exact science, obviously. I don't know if it's 60 or 80, and I don't know if it's exactly 2 years, but much faster. How do we do this? Well, this is what NAUTO does. We take very simple embedded devices, our first-generation devices in the middle on the left there, which is built around a smartphone with a Qualcomm Snapdragon processor. The right is a custom-designed version that you'll be able to get later this year that basically is built on a similar mobile architecture, but more computing, more memory, and a lot more thermal capability to handle the automotive environment than the cell phone that's really designed to live in your pocket, which is a relatively mild thermal environment. Taking any kind of car that's on the road today. So this doesn't mean sell your car, buy a Tesla. This means take any existing delivery truck, taxi, your existing Uber vehicles, or any delivery vehicle that are typically cheap. They don't have much electronics in them. They don't even have collision warning systems typically, and upgrade them They talk to each other, they talk to the brain in the cloud, and they can begin to give professional fleets, which is where we're starting, the kind of data that professional fleets need to understand who's driving well and who's not. Are they good at nighttime or the daytime? Are they good on freeways or on city roads? Because it turns out those are big differences. We have drivers that on average look okay, but they're terrible at night. Some drivers are terrible on freeways. Wouldn't you want to know before you deploy that guy to the graveyard shift? And similarly, you can get insurance benefits. What do? The core of the system is deep learning and computer vision united. So instead of just the vehicle, which is where telematics is today, right? You track the vehicle movements with GPS, you get accelerometer signals of how fast is the car going, how much did it brake. You can actually get driver behavior in context. So if you look at the driver, an inward camera that isn't recording the driver, but is monitoring real time what's the driver doing. Did you see that stop sign? Did you see the car ahead of you? Did you fall asleep? Are you talking to a passenger so you didn't see that accident about to happen out here? All of that stuff we can detect in real time. And obviously intervene, give you a warning if there's still time left. Again, this is an upgrade on the car, so we're not talking about the car taking control and steering you around at this point. Obviously in the future that will be the case, but for now, it's just helping the driver, augmenting that 360 perception. You can also get a glimpse of the future. If you start turning your head like this, I know I'm about to change lanes or make a turn depending on the outside context. Speaking of outside context, I can see all of the other cars around me. Instead of trying to guess whether hard braking is bad or not by watching your foot go from gas to brake pedal, I can actually see, did a child just jump out in front of the road and you should have braked but you didn't? Because by the way, that's improper braking even though there was no hard braking there, right? Or did you actually fall asleep and then at the last minute you woke up and you almost hit somebody? Again, blow right through a stop sign. No braking event. Today wouldn't be scored negatively by an insurance company, but with vision, obviously, we can see that happening. I want to highlight just how important this is, because today, a bunch of you are subsidizing the rest of you in your insurance. 20% of drivers you can see on this chart in the black line do not have accidents ever in their life. 20%. So the 20% of you that don't have accidents in your life, you're subsidizing the guys on the right-hand side of that chart. By the way, the worst guy, and it is a he, has 15 accidents a year. Shouldn't be driving, right? Probably driving illegally without a license, without insurance, because he can't get insurance at those accidents rates. There's no way to detect that today. The green line is today's best usage-based insurance. You can see there's a 5x gap to what the real data says with computer vision, because 3 out of 4 accidents are never reported in any government or insurance statistics. So we miss 3/4 of the incidents. Now think about the fact that with computer vision, I can detect near misses. I can see you almost hit something, but you didn't actually. Now I'm getting 40 times more data on how are people actually driving. And obviously that allows you to coach people in a professional fleet context. You'd say, if you're really at that extreme end of the chart, I don't want you as a professional driver, right? Go get a different kind of job. Lastly, in the middle, all of us have accidents some of the time, except for that 20% on the far end. And the reason is we get distracted. Most police statistics tell you speeding, but that's because the cop records speeding when he doesn't know what else caused the accident. The real cause, when you look at actual real driver behavior in the field, more than half of it, distraction is a major contributing factor. And it's getting worse. The reason driving is getting worse for the first time in about 60 years in the last couple of years is because we all carry these things. We have a great source of distraction with us all the time, and we use it more and more for different applications. What if I could detect distraction in real time? And what if I could, from context, know whether distraction mattered at this point? Right? The law says don't use your phone in the car unless you're using it for maps, which sort of like, okay, it's safe to do this for maps, but it's not safe for texting. Help me understand that. In reality, we all know intuitively if I'm stopped at a red light or I'm in a parking space or I'm in some other area where I'm not moving anyway, glancing at my phone's probably not a big deal. If you're doing it at Cesar Chavez and 101, which I'll show you more about in a moment, terrible idea. That intersection is 100 times more dangerous, that on-ramp, than any other on-ramp on 101. So probably not a good place to be distracted and use your phone. You want that kind of context-sensitive system. So this is how we do it. The left side is the outside view of the system. Again, not what we show the driver, but what the system sees. The right side, you see the inward. Outside, we detect vehicles. Nothing shocking there. You've seen NVIDIA and many others do this. Classifying them, estimating the distance, detecting stop signs. You know, Mobileye's been doing this for high-end luxury cars for a long time. But remember, this is a $399 cell phone-based device. This is not a $100,000 car, right? You can upgrade a car into this. On the inside, we're tracking the driver's head, the motions, where the eye gaze is, whether they're distracted or not. And then we're using visual odometry to see where you're going much more precisely than GPS. This is the comparison. The left-hand side is the high-end version of the algorithm that we run the training on, running on NVIDIA. And the reason it's running so jagged has to do with the projector, not actually with the algorithm. The right-hand side is the same algorithm running on a Snapdragon. And you can see, if you watch very closely, there are some very slight accuracy differences. But it's very small differences in performance in the feed-forward mode. Not obviously, you wouldn't want to do training on a Snapdragon at this stage. But you train on a fast chip, and then you deploy on a lightweight processor that can do the same thing in real time with nearly the same accuracy. I mentioned the distraction. So here, you can see in real time detecting whether this driver is distracted by food, by mobile phones, by taking their sunglasses on and off, by talking to other passengers. This particular section doesn't have any other passengers in it, but there'll be more later. So again, I can be context sensitive of, does it matter that you're distracted right now? And I can put this in your car today. For any of you who have teenagers, anybody out there who has teenagers? Are you scared to death when they're learning to drive? You should be, because on average you have 2.5 accidents before you learn how to drive. It takes you 7 years statistically to learn how to drive. And I don't mean the get in and know how to motor around. I mean be safe like a mature driver. It takes 7 years. And lastly, because it's deep learning, we're not programming in any specific assumptions. This algorithm was trained on data from all around the world, all different weather conditions. And you can see it not only handles Highway 101, which is pretty standard. Almost every vision algorithm nowadays does this if you're working in the automotive space at all. But we do Bangalore, we do Denver in the snow. We've done left-hand side driving in the UK and Ireland. And if we get through enough of these frames with the projector here, you can actually see some of these other environments yourself. We'll see. So accuracy is very robust. I'm really only showing you the tip of the iceberg because I'm showing you the vehicle detection, but obviously you can do the same for signs, for other dangerous conditions, for turning behavior, and for many other things that you can see in a driving environment. Down to, is that parking space open or not? So remember when I said 1/3 of all traffic is looking for parking? What if every car just shared the open parking spaces and every other car could benefit from those? Very simple idea. The networking part of that's not hard. It's the initial data gathering that you need a lot of distributed devices to do. So I'll skip the rest given that it's so slow, but here's one of our test vehicles in Mexico. And at the end of the video, you'll see high-speed police chase. Happy to show it to you another time. Last 2 slides, and then I'll turn to questions. What is the kind of data that we capture? Well, first of all, I already showed you we capture who's driving and how they're driving. So if you're in the car-sharing mindset and you want to share with somebody or you just want to ride with somebody, you want to know, how are they driving? Are they good or not? You know, what sort of person am I putting my life into their hands when I get into a Uber or a Lyft or a taxi? I mentioned that on-ramp at Cesar Chavez and 101. We've literally plotted for the entire Bay Area and for our other launch cities, where are the high-risk accident zones? Did you know that when you cross Market Street, there's 2 orders of magnitude difference depending on which street you choose of how dangerous that crossing is? And there's a couple of those Market Street crossings where you really are taking your life into your own hands. Left turns are 4 times more dangerous than right turns. Some of you may have seen a few months back, Waze acknowledged that yes, they'd saved you a minute or 2 of time, but they'd substantially increased your accident risk because they made you do funny left turns and U-turns that really don't make sense from a total optimization point of view. So now suddenly you can build that into navigation systems. You can build that into your logistics route planning for a delivery fleet. And lots of real-time maneuvers. The reason most people can't handle Manhattan driving is because there's always pedestrians. So if your model is anytime there's a pedestrian, I put a virtual gate down and I stop the car, guess what the user experience in Manhattan will be? That's great for your autonomous car. Sometime next year, I'll have turned that corner, right? What you need to do is actually understand how do real humans drive. So what we want to do is build that 20% of humans that never have accidents, build their driving behavior into the autonomous vehicle of the future. Because they drive mostly following the law, but they deviate from the law in all kinds of interesting ways. And there's a lot of communications act. Do I inch forward to message? Do I, in fact, turn away so that the person knows that I'm not seeing them and then they're going to yield to me? A lot of the facial behavior of what the driver does on the inside is actually signaling to pedestrians and to people around what's the sequence of turn taking that I'm going to follow? The bottom right is time. Risk is not equally distributed in time either. Here, one very simple example. If you follow the geek commute, you come to work late and you stay until late into the night or early into the morning, you're about twice as safe as the typical 9-to-5 office worker. So now you have another justification for your shifted schedule if you want, which is I'm actually just trying to drive safely. And Friday night, 6 p.m., is the worst time to be on the road. People are tired, they're inattentive. Typically you get evening, lower visibility environment, and you're starting to see the ramp up of drunk driving crashes, which continues deep into the night. So if you're building a collision warning system or you're building an autonomous car, wouldn't you want to dynamically change how conservative the car is depending on those circumstances, where you are and what time of day you're driving, right? And maybe if there's no traffic and it's on a Sunday morning while there's nobody on the road, you might be a little more aggressive. Similarly, if you're running late to a meeting, you might be a little more aggressive. And ultimately, your insurance shouldn't charge you a flat fee per year. It should say, depending on how you drive and when you drive and how late you are running typically, we're going to charge you a different amount per mile. Then we'd stop subsidizing each other. So take it back up a level. How does this help some of these billion-dollar problems that I mentioned at the beginning? Well, you can effectively do a Waze on steroids. Not just helping you route and figure out where traffic is, but actually get real-time data lane by lane. So I can tell you which lane to get into. I can tell you whether the carpool lane's moving or not. Many times I've been really frustrated because on Waze or on Google Maps or any of the current sources, I can't tell the carpool lane speed from the rest of the other lanes. A third of all urban traffic is parking, right? People just hunting around, circling. Same thing for a lot of taxis and Uber drivers, just circling, looking for the next ride. All of that can be addressed and go away. In fact, you see the value of parking spaces in San Francisco is already dropping 6-7% per year. Obviously, the value of housing continues to go up, so that's kind of interesting. It says that that's already embodied in the market mechanism. Safety, not just the obvious safety of keeping you out of crashes, but there's a lot of stolen cars. 1.2 million are stolen every year. A lot of those can be recovered if you actually detect when that vehicle shows up somewhere. Amber alerts. Right now we're relying on a human listening to their radio or keeping the function on their cell phone turned on to then actually look at license plates. What if we automated that when there's an Amber Alert? And lastly, a lot of accidents today are hit and run. Most pedestrian fatalities actually happening with hit and run attacks, so there's no evidence. You don't know how to prevent them. You want to know that record for a driver. I've talked about insurance already, shifting really the entire model from risk pooling. We all pay into a fund. That fund pays whoever is the worst risk, who has the most accidents, into a model of actually preventing, coaching, improving, helping you learn faster when you learn to drive, and then keeping you safe even while you're driving. Even though I'm a reasonably good driver, I love that feature because there have been a few times a year when I make a mistake, and it actually gives me a heads up and alerts me. So I want to know rather than get into the accident and just have a payout later. And lastly, come back to the infrastructure. I already mentioned that 8-fold productivity gain when we get to full autonomy. But even in the meantime, today we do planning for highways on data that can be as much as 10 years old because we only update the census data for what actually happens on our roads every 10 years. So the current planning data that governments are using does not include any of Uber or Lyft in its statistics. Think about that. If you're doing new road planning and you've never thought about Uber or Lyft because you have no data on them, you're certainly not coming up with the right answer for what to build next. So thank you very much, and happy to take questions.
Great, thank you very much, Stefan.
My pleasure.
So I've got a quick question for you. Going back to your ACEs analogy or acronym, out of that, which is the hardest of those problems to solve today for you, or what you've seen?
Yeah, so I think in terms of technology, the autonomy part is the hardest part. In terms of broad acceptance at very large scale, I actually think the sharing is harder. And the problem that hasn't been solved is the fact that we have kids and we have stuff. And where people typically are uncomfortable sharing is you've got soccer gear, your golf clubs, whatever else. Your car is basically a mobile storage unit. Right. And the next Uber will have to solve that problem because I think that's a multi-billion-dollar problem, which we're not working on, how to share stuff. The electrification, it's just a matter of getting battery costs down. It's well underway. And we can see the excitement around the Model 3 and the fact that it doubled the EV market in the US in 1 week is a clear indicator that $200 a kilowatt is the price point where the upfront cost is the same, the operating cost a quarter, it's a no-brainer. I'm going to go electric.
Got it. Great. Thank you.
Sure.
And I think looking at that broader market opportunity, you share some pretty large numbers. And so I think everyone is excited to see how that all plays out. And as part of that, you've clearly been engaged with some customers today to help build out your data map and test out some of your technology. What types of companies have you been working with to help you with that?
Yeah, so we've been very public that we're working with a number of fleets all around the US. We have some fleets signed up overseas already, but have not deployed any devices in fleets overseas. We've done test runs, as you saw in the videos. We work with over a dozen insurance companies on a variety of models, anything from traditional assessment of commercial driver risk, so more in the underwriting side, to actually automated claims. Imagine if you had actual video and telemetry of how the accident unfolded. You don't need to send anybody out anymore. They can instantly help you. In fact, the insurance can contact you to help you with the accident you just got into before you may have even reached out and called them and send the right emergency services. And we have a number of relationships that we haven't announced yet with OEMs. We're working very closely together. Stay tuned for more on that. Given the OEM product pipeline, you'll see a lot of those products only come to fruition in the future. So right now it's all commercial fleets. Eventually you'll be able to buy it as a consumer, but if you drive for Uber or Lyft and you're driving 80, 100,000 miles a year, then our product is certainly relevant today already.
Great, very exciting space. And I think we've got a few questions at the microphone, so maybe we'll start on the left first.
So really, a couple of questions. So, in the talks earlier, we saw accuracy metrics for ImageNet sort of classification. What sort of metrics are applicable in your domain? I mean, what's the accuracy metric? How do you define accuracy of a CNN in your domain?
So we define it the same way. We calculate an F-score for the false positives, false negatives. Depending on the application we're trying to do, we care more about the false positives or false negatives. For example, if I want to detect an open parking space, I want to be sure that's really open. If I occasionally miss one that actually is open, but I don't detect that accurately, that's fine, right? So we tune that for depending on what we're trying to detect. And our network, I'm not going to share the exact score, but we're better than any published score that we've seen for the vehicle detection that we're doing. Doesn't mean there isn't some other company inside doing something at the same performance level, but anything that's been published, we're already better than.
One more?
Let's take one over here first. Okay, yeah. Bruce?
Well, Stefan, I was wondering, you've seen obviously lots and lots of data. So I wanted to ask, do you think that human beings really should drive?
So I think I showed you the chart. A portion of human beings definitely should drive right now, because I think they're still better than autonomous systems left on their own. I intervene in my Tesla about once every couple weeks when it does make a mistake. And by the way, I push it to the limit like most Tesla drivers, right? I drive it on surface streets, which technically is not part of the official beta, but it's fun. If you're at the other end of the spectrum, those people really shouldn't be driving today. Now, today we don't have a very good way to detect those and then take them off the road. And I don't mean ban them, right? I mean just they should be in Ubers or should be in some other kind of shared infrastructure. I think there will come a point, but we're probably still at least a decade away, when we will start restricting human driving in certain areas. Because as I showed you, there clearly are some areas that are more dangerous than others. So there'll be country roads and remote areas where you can definitely have your pleasure joyride, where it's more fun to drive anyway, right? Because it's actually nature and you're not honking and stuck in traffic. But in urban areas, I think we're going to restrict the car use either to cars that have these augmented safety systems or that are fully autonomous. And down the road, driving may become a rare thing you do for fun, not something you do to get to work anymore most of the time. But the bar is very clear. You need the actual data on when is that crossover point to it being safer. Right now, we don't have enough data for any autonomous car to really know what's the full level of accuracy under all circumstances. We know it under the set it was developed and trained on, obviously. So, yeah.
Maybe just to be equitable, we'll have the gentleman behind you ask his question.
Yeah, this is a very quick question. So you mentioned you were running it on mobile platforms. Is that primarily a CPU implementation, a GPU, or shared between the two?
So the first version is the Snapdragon 810, the second Snapdragon 820, working very closely with Qualcomm, and we use both the CPU and the GPU on those devices.
Okay, thank you.
So you mentioned 101 and Bangalore in the same breath. So is it one network, or do you have completely different networks?
So we have trained multiple networks for different circumstances. We believe that ultimately to get to very, very high accuracy in different environments, because they are so different, you'll want to switch networks. And that may be switching for when you ship your car to India. That might also be when you go cross country from here to Boston. As many of you who've driven in Boston know, it's a very different driving environment. Certainly, they're very different, and you can get much higher performance for rain or snow if you have a dedicated network trained on that kind of data or nighttime. And so we're looking very closely at what's the optimal number that you really want to have. Obviously, on a portable, small retrofit device, you're not going to have 3,000 different networks for different conditions, and there's some switching time involved. But it is clearly better to have tuning into different environments. And we're learning a lot about individual different driving styles, different kinds of vehicles, but also geographically and environment-driven differences in driving. Driving is much more nuanced than most people think. And so if you start from an engineering view and say, I'm going to build good traffic laws and good engineering physics principles into the car, and that's how my autonomous car will run, that works perfectly fine on highways, which are limited access and very clearly delineated. That gets harder and harder as you get into messy environments that, there's a joke about if you want to know how many lanes are on this highway, the question is how wide is your car, right? So once you're in those environments, then all bets are off.
Great. Well, Stefan.
Thanks.
Thank you very much for excellent talk.
My pleasure.
Great.